Hello, welcome to Shine Solutions. In this lecture, we will discuss JAM 2022 Chemistry question paper from questions 11 to 20. Okay, let's start. Question number 11, the major product from the following reaction. This is a very good question. Actually, this question will test our knowledge, the basic knowledge about the organic chemistry, the fundamentals of organic chemistry. So we should know the fundamentals very well, otherwise we can't do this problem. Okay, so what is the question asked? It's a simple question. NaCN says Cn minus is the species which attacks the OTS is the living group. It will attack here and OTS will be removed. But we should know the mechanism because it's a substitution reaction. If you go through the options, you can say it's a substitution reaction. There is no elimination process. So Cn is a nucleophile and it attacks the carbon and eliminate the OTS. That's what is happening here. We should know whether it's an SN1 or SN2 reaction. So Cn is a strong ligand and OTS is a good living group and polar protic solvents are given. So it's an SN2 mechanism. So if it's an SN2 mechanism, the incoming nucleophile will attack the carbon from the opposite side of the living group. OTS is the living group, so it should be nucleophile should attack from the opposite side of the OTS. So for that, we should convert this system to Sohos. Otherwise, this representation is a Fisher representation. With the Fisher representation, we can't do this problem. We should convert this to Sohos. So first, we should convert this Fisher to Sohos. For that, you should remember one thing. Fisher conformation is the representation of an eclipsed conformation. So how can we convert this to Fisher? That's what I am showing here. You can see it here. This is the representation of this molecule. Me should be here. Okay, Me here and pH here. Okay, this is how we should represent this Fisher conformation. Sorry, Fisher to Sohos. Me here and OTS on the right side. OTS here, hydrogen here. Okay. Similarly, hydrogen here, Me here. Okay, this is the representation. And we should place this living group here. So for that, I am rotating this carbon by a 120 degree. So we will get the conformation like this. If I rotate it, OTS will be here, hydrogen here, Me here. That is what we will get. pH, Me. Now our nucleophile is Cn minus. Cn minus will attack from this part. That means from the opposite side of the OTS. So it will be eliminated. So we'll get the product like this. So we'll get the product like this. So the now system is like this. So it will become eclipsed form becomes staggered. Cn here. Me, Me. Okay, this is the situation and pH here. Now we should convert this Sohos again to Fisher. For that, we should convert it to eclipsed conformation. So you can see it here in the options. pH and Me are in the opposite sides. So here and so we should convert this to eclipsed conformation. So this is the representation. Eclipsed conformation. After converting to eclipsed only, you should convert this to Fisher. So Fisher is the representation of an eclipsed conformation. Okay, you must remember that. So we should keep the pH and Me. In the option A and B, you can see Me and pH in this part. So you should keep Me and pH here and here. So for that, I just place this Me here. So Me here. So if I rotate it by 60 degree, I'll get this, and Cn will be here, and hydrogen will be here, and pH is already occupying on this part. So this is the representation. So you can see hydrogen and hydrogen are on the same side. In option A and B, hydrogen are not on the same side. So the A and B is not the answer. Now we should check for the option C and D. For C and D, Me groups are on the top and bottom. So to convert this to eclipse conformation, we should keep the MEs here. Okay, you should write the structure like this. Me and Me should come here. Okay, so if I place this Me here, Cn will be here, hydrogen here, and if I place this Me here, so this hydrogen will go there and pH will come here. So pH will be here, H and Me. So this is what we will get. Okay, so if we convert this to Fisher, we will get the product like this: Me and Me here, top and bottom, and H and pH on the same side, Cn and H on the same side. Okay, so if we look at the options, you can say Cn and H on the same side. Okay, so option C is the right answer. You will get the option C. Now question number 12. Now question number 12. And this is a question from the NMR spectrum. An organic compound having molecular formula is given. So if you look at the proton NMR spectra, if we check the IR spectra first, 1720. This is corresponds to CO stretching frequency. Okay, in all the options you can see CO is present. Okay, so we can't eliminate options with this one. And one important thing, if you are solving the NMR problems, you should eliminate the options. That is how we should do the problems. Okay, check the NMR peaks and eliminate options. That is how you should approach the NMR spectrum problems. Okay, so first one, 3.62 hydrogen doublet. 3.62 hydrogen doublet. So 2 hydrogen doublet. You can see here 2 hydrogens are present. It can give 2 hydrogen doublet. Okay, here in these options there is no option. If you look at the option A, Me is present here, OMe, there is no, it will give 3 hydrogen singlet, and this also give 3 hydrogen singlet. Okay, so these options can't give you 2 hydrogen doublet, and we have 2 hydrogen. Okay, here we have 2 hydrogen, but these 2 hydrogens will give you a singlet. Okay, so if you check the 3.62 hydrogen doublet, this peak, you can eliminate option A and option B. Okay, in option C and D, you can see protons, which can give 2 hydrogen doublet. So we can eliminate option A and option B. Now 3.83 hydrogen singlet. 3.83 hydrogen singlet is a peak for OMe. Okay, so in both options, you can see these peaks. 6.72 hydrogen doublet. This is from aromatic region. In aromatic region, you can see only 2 peaks. Okay, 9.72 1 hydrogen triplet is a peak for aldehyde. So in both options, we have aldehydes. So if you look at the peaks at the aromatic region, you can see only 2 peaks present. If you go for the option D, you can see this hydrogen, this hydrogen, this hydrogen, and this hydrogen. Okay, we have this hydrogen and this hydrogen, all the 4 hydrogens are in different atmosphere. So it should give 4 different peaks, 4 different peaks in aromatic region. Okay. Option D will give you 4 different peaks in aromatic region. But if you look at the options, option C, only 2 peaks are possible in the aromatic region A, B, B. Only 2 peaks are possible in the aromatic region. So these options matches option C. So answer is option C. Question number 13. This is also a very good question. It will check our basic knowledge in organic chemistry, fundamentals of organic chemistry. So earlier in the question 11, we did the substitution reaction E1 eliminates, sorry, SN2 substitution reaction. In this particular reaction, it's all about elimination reaction, because you can see a base is given, NaOH and ETOH, it's a base. In the presence of a base, elimination will take place. Okay. So 2-chloro 3-phenyl butane, 2-chloro 3-phenyl butane. So that is what is we are going to. All right. Okay. So butane will be like this. Okay, these are the possibilities. So if you number the system 1, you will go for this one. 1, 2, 3. So it will be anti-clockwise. Hydrogen is lower priority group is below the plane. So it is S. And in this case, and for second carbon, the first number will be for this one. 1, 2, 3. Clockwise, lower priority group below the plane R. Okay, 2s 3r is structure. What is the question given? 2s 3r. So this is our molecule. Okay, this is our molecule. This is the molecule given. So if you represent this one in the Sohos, it should be, it's an staggered conformation. So okay, above the plane chlorine, here pH, H. This is the molecule. So only after converting to Sohos, you should do the elimination of substitution reaction, especially if question is asked about the stereochemistry. So chlorine is the leaving group, and the 2 leaving group, it is all about E2 elimination. So 2 leaving groups should be anti-periplanar to each other. To make these 2 leaving group anti-periplanar to each other, you should keep this chlorine here and this hydrogen and this chlorine are the 2 leaving group that group should be anti-periplanar here and here. So that is the best way to place the leaving group. So you can easily identify the anti-periplanar concept. Okay. So if you want to place this chlorine, you should rotate it by 120 degree. If you rotate it like this, chlorine will be here, hydrogen will be here, and CH3 will be here. And similarly here also, if you rotate it like this, hydrogen will come here, pH will be here, and CH3 will be here. So that is what we will get. Now it will eliminate like this. So you will get the product like this. Okay. So you can see CH3 and hydrogen are on the same side. Ready? Here you will get CH3 and hydrogen. You will get pH and H. pH HCS. Okay, this is what you will get if you number it 1, 2, 1, 2 from 1. So you can see 1 and 1 are on the same side. So this is a Z's conformation. Okay, Z conformation. So the answer will be Z 2 phenate, option B. Question number 14. The major product formed in the following reaction. So this is also a question from organic chemistry. This is famous Paulsky rearrangement. Alpha halo ketone in presence of a base. Okay. So what happened is we have a proton here, base will remove this proton. So we'll get the product like this. Okay. Enolite ester forms, then it will attack bromine and you will get the product like this. Now OMe minus, so we have bromine here. OMe minus will comes to attack this carbonyl carbon and it will eliminate like this. So you will get ready. The next step, when it comes back, it will cleave like this. So you will get these two groups and double bond O, OMe here and a bromine here and a carbanion here. Next step, this will eliminate the bromine. So we'll get option C as the answer. Okay. Option C is the answer. Pavolsky rearrangement. Question number 15. It's a direct question. The reactivity order of phenol derivatives. So we can we know OSIMe3 is a group which is used for the protection of phenolate ion. So after protection, the reactivity will be very less. This is highly reactive compared to all other options. So first will be the most reactive, then comes 3, then comes 2. Option D should be the answer. Answer is option D. Question number 60. All possible lattice types are observed in the. This is also a straightforward question. We should know the answer. No explanations is needed, I think. The answer is orthorhombic crystal system. In orthorhombic crystal system, all possible types of crystals, lattice types are observed. Okay, option D is the right answer. Question number 17, structural type of B10 H10 2 minus and B10 H14 respectively are. Okay, so it's all about boranes. For boranes, we should know these things. Bn Hn 2 minus is closo. Bn Hn plus 4 nido. Bn Hn plus 6 arachno. Bn Hn plus 8 hypo. Okay, so we should know these things. If you know these things, it's very easy. This will be closo. This will be B10 H14. So it will be nido, closo and nido. Option A is the right answer. Question number 18. The ground state and the maximum number of spin allowed electronic transitions possible in a CO2 plus tetrahedral complex respectively are. So this is a question from electronic spectra of complexes. To solve this question, we should know the Forgel diagram. So It's a cobalt 2 plus system. Cobalt 2 plus means it's a D7 system. It's a D7 system. It's a D7 system. So we should know the orbital diagram for D7 system. This is the orbital diagram for D7 system. The orbital diagram, it's not only for D7 system. Its right side represents D2, D7 octahedral and D3, D8 tetrahedral. And left side represents D3, D8 tetrahedral and D2, D7, D2, D7 octahedral and D3, D8 octahedral and D2, D7 tetrahedral. So question is about D7 tetrahedral. So question is cobalt 2 plus tetrahedral system. So this is a D7 tetrahedral system. So we should look for the left side of the orbital diagram. So these are the allowed transitions A2 to T2, A2 to T1, A2 to T1P. So these are the three allowed transitions. So answer will be A2 and 3. So answer will be option A. Next question. The correct statement about the geometries of BH2 plus and NH2 plus based on the valence shell electron pair repulsion VSEPR theory. So if you go for the VSEPR theory, boron has 3 electrons outside. So boron has 3 electrons. The electron configuration is like this. So boron will form 2 bond with 2 hydrogen and there is a remaining electron here, but in this molecule we have positive charge, so this electron will be missing. So this will be like this: 2 bond pair, 2 bond pair only, 2 bond pair plus 0 lone pair. Geometry will be linear. Okay, but for NH2 plus, the structure will be like this. Nitrogen has electronic configuration of boron is like this: 2s2, 2p1. So that is why we have 3 electrons here. In case of nitrogen, we have 2s2, 2p3. Okay. So this is the electronic configuration of nitrogen. In this case, nitrogen have 3 electrons in the p orbital. So that is what we represent here. If this form a bond like this, it will be like this. It can form a bond with hydrogen, and next it is forming a bond with hydrogen H plus, but to form a bond with hydrogen, it uses these 2 electrons. Okay, not like BH2. So it is like a coordinate bond. So we should take the 3 electrons for the configuration. So the structure will be 3 bond pair plus 0 lone pair system. So the structure will be trigonal planar. Okay, so the answer will be option B. BH2 is linear and NH2 plus is trigonal planar, like that. Last question 20. The order of increasing CO stretching frequencies in coordination compounds. Okay, organometallic molecule. So what are the questions about the CO stretching frequency? So we should know the bonding in metal carbonate. To answer this question, so metal forms bond with carbonyl group like this. Okay, it will have a sigma bond like this. To form this sigma bond, carbonyl group donates the electron to the metal. Along with this sigma bond, there are pi bonds. Okay, to form pi bond, metal donates electron to the carbonyl group. Okay, to how this metal carbon pi bond is forming? It is the metal orbital is filled d orbital of metal and the orbital involved in CO is 5-star antibonding molecular orbital of CO. So the electron is flowing from d orbital of metal to the 5-star antibonding molecular orbital of ligand. So the after effect is like this. If metal have high electron density, the back bonding will be very high. So electron will flow from metal to ligand. So what is the ultimate effect is it will decrease because the electron is filling on the 5-star antibonding molecular orbital. So it ultimately decreases the CO bond strength. Okay, if back donation increases, CO bond strength decreases, bond strength decreases. So that is how it affects. So if you look at the options and if you look at the questions, you can say the question is about the CO stretching frequency. So how the bond strength and the stretching frequency related? Actually, the CO stretching frequency is directly proportional to bond strength. Bond strength increases, CO stretching frequency also increases. So that's how it is related. So if you look at the options, you can see CO has minus charge, CO plus Cu has plus charge. If metal has plus charge, the back donation will be less, so it will have high electron. It will have high bond strength. Okay. If back donation increases, bond strength decreases. That is the idea. Okay. Negative charge increases, bond back donation increases. So 2 plus 2 minus has high electron density. So in this case, it will have high back donation. Okay, bond strength will be, so back donation increases. What happened? Bond strength decreases. So it will have high back donation. So bond strength will be very less. So stretching frequency will be less. This is not the answer. So if you look at the option B, positive charge will have low back donation and bond strength will be high and stretching frequency will be high. So the option B is the right answer. Okay. So these are the 20 questions we discussed in this video. In the next video, we will discuss question number 21 to 30. Until then, bye.